I will do it
That's
for
cool,
you.
mate. So this is a piece of material. What is the ratio between these two bits of material, between these two, between any two bits of material? How are you going to determine? Oh, how are you going to work out? Go for it. The answers are at the bottom of the thing, so don't look. Oh, you're welcome to. Or don't, or do, or don't, whatever you feel like. It's a rather lovely challenge. Camilla? You want to do it now, you mean? Everyone's watching?
No, but like when you're doing it, can you put it in the box and make it inside the box? Because then you know what the square you're meant to look like.
It's far more complicated than that. But I would have known.
Doesn't even fit in the box.
Jimmy sat there looking, saying, pick me, pick me, pick me. The next lot of material you guys already recognise. A lot of schools have it.
No, I didn't. Sorry, can I just ask? This should make a perfect square.
No. I'm just
You
trying to
just want
put
it
it
in
in
the
the box.
All right, I can do that.
You can put it in. It's not part of the exit game at all. You'll recognise a lot of stuff in here. A lot of schools have got this, but they don't know how to do it, and it just sits there getting dusty. And the reason is because they don't have this, and they have no idea what they're doing. Okay? I'm going to offer you an opportunity now. You already know a lot about what's in here. Are you excited?
Yes.
It's a pretty cool box. Ready? Are you ready?
Just open it.
Beautiful. What do you recognise immediately? Shona, we need your expertise. What do you recognise?
Oh, it just
What do you
clicked.
recognise?
Oh, the colour.
Yeah.
What do you mean the colours?
Because they're the same as the checkerboard.
Yeah.
Which, by the way, I just did. just to throw it out.
You have to, didn't you? You absolutely had to because it bubbled over. It's part of. It's so important. 1s and 2s and 3s and 4s and 5s and 6s and 7s and 8s and 9s. Okay? What is this? Thank you.
9 cubed.
What is this?
9.
81. Yep, 9 squared is 81. Cool, easy. So
Yeah.
far so good. Everyone got it sorted out. Everyone knows that if I take a cube, mate, congratulations, nice feeling. Whatever you've just done looks good. Can you see it? Feel the joy. No idea what
This was I had 4. It made sense.
I don't know.
Did I get it right?
I think you did.
we could hear your joy. This is a cube. I want to make a bigger cube. This is 6 cubed, right? How do I make it? If it was a square, what would I have to do? Tell me. I had a square. How do I grow a square?
On 2
One,
sides.
N, if you like, N, and a 1. True?
Mm-hmm.
A little bit like this, you mean. This is 6 cubed, so I need N, and this is where these guys come in. And a 1.
Oh.
Can you see that? But this is not a cube. I need
The height.
another one on top, and therefore I need another couple of these guys. It's good as covered. And I need a 1.
So you can work out the numeric value of that cube using the colors.
This dude here is 7 cubed, would you agree?
Yes.
6 plus 1 cubed, which is the same
Ah.
as 7 cubed. Yes? She looks like she's in love. She's like, "Ah." And it really is. It's a moving experience to know that these guys are your friends. It's not going to stay up, but you can imagine. See what I've done? Let's go back through that. I started off with 6 cubed. I added on 6 squared, 6 squared, 6 squared. Plus I added on 6 plus 6 plus 6. And I added on 1. Have you seen this pattern anywhere before?
Mm-hmm.
Trinomial cube? You're right, binomial golden beads, because point, line, plane, solid.
Ah,
It's
yes.
exactly the same, but it's a different base. Now we're talking about 6 is the biggest. Whereas over there we talk about 10 is the biggest. This is beat, 5 is the biggest. This is 3, this is 2. But also, can you start to feel them all merging in now? I didn't do the decanonial. Oh my god, I've got to, don't I?
Oh, at all.
I've got to. I haven't
Oh,
done
yeah,
it.
you got to. So that's...
All right, there's no choice. I have to.
Yeah.
Sandy said, actually, why don't we start it going? decan on there. Do you want to, or do you watch this and we can do it afterwards? We've got over lunch. You can't not do the decan because it really
Yeah.
brings everything together.
And I've got 21 non-variable responses.
Oh, okay, cool. Okay, n cubed plus 3n squared plus 3n plus 1 is what n plus 1 all cubed is. N cubed plus 3n squared plus 3n plus 1. You recognise that from the trinomial cube? Yes or no?
I'm pretty sure even my math teacher would not know what that means.
N plus 1, oh, you mean but we teach it, we have no understanding that it's growing a cube. It's growing a cube, but I really like what you said. This is point line plane solid. As it would be if this were the deal. What do you think I'm going to need if this is 3 to get it to a 4? Just throw it out there. What could be useful? To get from 6 to 7, I needed all that. What do you think I'm going to need for this?
The same. 3
3
squared
Yeah, what else?
3 threes and 1s.
and
Yeah. These are quite
and
sweet.
ones.
This pink is quite sweet, isn't it?
And
Well,
a
they're
1.
exactly the same. And a 1?
And a
Always have
1.
a 1. Interesting, always have a 1. Always need a cube in the corner. Didn't we always have a cube in the corner, both binomial and trinomial
Yeah.
cubes? Choice. Shall I test it out?
Yep.
You reckon this will get me to a 4 cubed?
Yes.
You sure?
Totes.
Totes. You're totes sure. If these are the same, woohoo! It's just a little bit satisfying, isn't it? Smug City. But going up by 1 cube is a bit boring. I can do 1 cube, yawn, yawn, yawn. Give me something easier. Give me something more interesting. It's too easy. What about n plus 2 cubed? I want to go from 6. Not to 7, not the next door one. I'm going up to 9. What do I need? Oh, 6 to 8. So 6 to 8. I can go to 9. I go to 9.
Sure, it's not going to work.
Well, I know what will work.
Round's 8, I know round.
What would you like me to do?
Go 9.
No,
No, just with what you were suggesting. Yeah.
So, in order to get this one up to 9, I don't just need 1 because that'll take me to 7. I don't need 2. it'll
You
take me
need
to
3.
8. I need 3. True? Am I
Oh,
correct?
Yeah.
9 now.
So you need another 6 cubes.
Yep.
2.
Yeah.
And then, what else do I need?
3 on the other side.
3 up this way?
Yeah.
3 up front.
Yeah.
Yep.
Yep.
Yeah.
Just hoping that I've got enough of these. How many of these am I going to need?
9 on a
I need 9
On
in
a
here, 9 in here,
there.
and 9 in here. I just don't think I've got enough, but you know what I'm talking about.
Yeah.
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 And a child at this age there, probably, what are we doing? You being probably 9 years old, would know about, we don't have enough. 9? When did you do Kiwi?
high school. Yep.
High school, you should be doing relationships. You should be learning how to drive an adult body, because that's what you're interested in doing. What cube will go into that little corner?
3.
Will we have got to a 9 cube?
Yeah.
Everyone know how to cube now?
Yeah.
Yes.
Would you like to find out how to cube root?
How to what?
Cube root.
Yes.
That's the like dividing.
It's just the opposite.
Oh.
Yeah.
Okay.
What's the cube root of this one?
I don't know.
How long is along one side? 9.
Instead of having the 9 lines, could we have 2 of the 3 cubes?
I've only got 1 cube.
But if we had more, would that?
Well, that would be 3 and that would be 3. That would be 6. Yeah, that would work. But the material doesn't extend that. Okay, it's quite an expensive piece of material. A lot of people have it. Very few people understand how to use it. Let's say I had a number. How would I cube root a number?
Find the length of this.
Brenda?
Length of the edge.
Yeah, we want to find the length of just one side. So last time when I did it in 2 dimensions, I divided the the pottles up into twos. Do you remember me doing that?
Mm-hmm.
What do you think I need to divide the pottles up into when I'm doing 3? Cubes. Yeah, exactly right. I need to divide the number up into groups of 3. So say I was trying to find a cube root of 328,917, just because that's what I'm interested in doing. In fact, does the number matter?
No.
It's just the fun of doing it, isn't it?
Yep.
Yeah.
Yeah, you guys are really good. Sorry, I have ruined you for the rest of the year. Because this morning you've agreed with me when I said that maths is not about getting it right and that the number doesn't matter. It's the process. It's really hard to mark that though. How do you set a test?
You can't.
You see why Montessori kids go test? What? Why would you be interested in the result? Were you interested, Shana, were you interested in the result when you got it? Or just that it came out?
Just that it came out.
It doesn't matter what the number was. You wouldn't want to be judged for the rest of your life on that number.
Mm.
And they
Kids
are
are-
moving away from that now, though, aren't they? If the children get the strategy right, although the answer is wrong, they will. I mean, I still agree with
I think
that.
in a really condescending
They are
way
moving
because
away.
the child has to talk about the strategy in the way that the adult
Understands.
I think it's all wrong. I think it's more and more poor teaching, to be honest. I don't think it's effective. What's joyous about mathematics is finding patterns in relationships, not remembering what strategy was appropriate in your life. Anyway, you would take the number and you divide it into Q3. 3 groups, 3 hierarchies, and then you take the biggest cube you could in that hierarchy. Okay? So say it was 328. I think was the number I used. 328. What's the biggest cube in 328? We don't know our cubes times tables very well. And that's fine, because you haven't done lots of... Where will you have seen a cube of a number before? The long bead chain. Yes, the children already know all of these cubes. They already know. So if I said the biggest one under 328, they would be able to point very quickly to whichever it was. We know that 5 cubed is...
225.
Yes, and we know that... that's 5 cubed. 6 cubed is...
No clue.
What's 6? 6 is a 36. 6 times 6 is...
36.
Remember the 3. 6 3s are 180. Add on a 3, 210. 216. So this is going to be our biggest cube. So when you've got 228,000, this is our biggest cube. And then you go down. And these would be thousands. And it's exactly the same hierarchy. Remember, this would be units. And then these bars out here would be tens, because tens are bars, remember? And then the flats would be hundreds. And then
That would be
base.
thousands. Can you do just a quick, go through with the material of how you would find out?
It's just because we need quite a good facility for the use of the cube. We'd keep on going to the calculator. Do you understand what I'm asking you to do? The 328?
Mm-hmm.
1,000,
So finding the biggest cube, yes.
biggest cube in that 3, and then you've got so many left over and you're going to subtract it all out. So you would actually make that number.
Mm-hmm. With the cubes, yes, I can see
Do it
that.
with golden bead. It'll make
Okay.
so much sense to you. Go and get 328,000. You're going to have to make up a thing called a 300,000 because we don't have the physical material of it. If you want to see it in materials, because we're just tipping over now into abstract, you present the idea in materials, but it's so much faster and so much more efficient to do
In abstract.
In abstract,
Yeah.
yes. But you need to understand the process. Yeah.
Yeah, that's sort of what I'm
I
trying to
think it would be easier if you'd done the square root a few times first, and then as soon as you hear me say, find a cube, and then build the biggest square
Yep.
as you can, and then as many squares out this way, take away as many squares as you can, and remember the units, and then do the hundreds, the tens, the units, all the way down.
Okay.
It'll come through. Cool. Do play with this. It's I think it's beautiful actually. It's just that it's very rarely used in materials. Almost never. Cool, we're starting to play around with